Hello everyone. Now in this video we are going to learn how to draw the projections of a cone when it is inclined to one plane. In the previous tutorials of projection of solids, we learned how to draw the projections of a solid when their axis is either parallel to VP or HP, and from this tutorial onwards we are going to learn the projections of the solids when its axis inclined to any plane, either HP or VP. As of now, in the present question, we can see that draw the projections of a cone of dia 60 mm and height 90 mm is resting on a point of its base on HP and its axis is inclined at 35 degrees to HP. So from the question it is confirmed that the solid is a cone of a dia 60 mm and height 90 mm and it is resting on its base with a point on HP, and also its axis is inclined at 35 degrees to HP. So before going to draw, let us have a look how the cone is resting. According to the question, you can see that the circular cone is resting on HP or one point of its base. So before resting on one point of its base, you can see that the cone is resting on HP with its base. So when it is resting on a HP with its base, the front view appears as a triangle, top view appears as a circle. So first we'll draw, when its base is on HP, we'll draw the projections of this one in the AutoCAD. Okay, so first I'm going to take the circle because the top view gives the true shape. Dia 60 mm, so radius 30. Okay, and now I'm going to draw the front view with the help of projectors. Okay, okay, here I took only the four points as a diametrical points. AB is one diametrical point and GD is one diametrical point. Whereas in the 2D projections, I split it into 8 parts because if we divide or split into more parts, we can get the very smoother curve for the drawing. So that's why here now I'm going to divide this circle into 8 divisions. DIV, enter, select object to divide, number of segments 8. Okay, now we divided this circle into 8 segments. You can increase the number of divisions also. The more the number of divisions, the smoother curve you will get in the second stage. Now to highlight the divisions, I am taking the P type, enter. Always use cross mark. 3, set size in absolute units. Okay, yes, perfectly we marked all the divisions. Now it's time to give the okay, let us take, now I'm taking 5 angle, rotation angle 0. Okay, this one I'm taking it as A, B, C, D, E, F, G, H, and this is the apex point. Let us denote it with O. Okay, perfect. We finished the top view. You can see that when you see from the top, it appears as a circle, and we completed this one. And now when you see from the front, side, this side, it appears as a triangle. Now up to here we draw the projectors, take a line, and from the center you draw the height, which is axis height is 90 mm, 90, enter. Okay, now connect from here to here and from here to here. Yes, we finished the apex point. Now I am drawing the base. Don't forget to draw the base. Okay, selected this one. Okay, now it's time to draw the projectors from the divisions also. Okay, Yes, and from this, yeah. Okay, if you observe carefully, these lines, every line is of generators. This one, this one, this one is everything is of generators. But always we need to highlight only the outer one. This is the base and this is a generator, this is a generator, everything is a generator, but only highlight the exterior one, this one and this one. Also select the top view also. Okay, I'm giving the color. Coming to line thickness, select only this. I'm taking 0.4. Line weight display on. Line weight display LWD, enter. ON, enter. Okay, LWD on. Now let's give the notations for the front view. So this is the apex point. In the top view we gave it as O. Now we will give it as O dash. Yes, O dash, and then this is the A dash. And coming to here, this is here, these are all generators. It's not about the edges, it's not about the corners, so there is no case of visible and invisible points here. So that's why just I'm writing as H dash comma B dash, and this is the one G dash comma C dash, and this is F dash comma D dash, and this one is the E dash. Once again I am saying, so this is a circular base, so to get the apex point, generators are useful. These generators are imaginary lines, so there is no case of invisible and visible lines here. So that's why instead of brackets I am taking H dash comma B dash. Okay, now DDI, dimensioning diameter, DDI, dia 60, perfect. And now DAL, to represent the height of the axis. Perfectly we represented 90, dia 60, 90. Okay, stage 1 completed when the base is on HP. Perfectly we finished. But in the question they asked us, it is resting on one point of base. Out of so many points on the base, it is resting on one point, and also its axis is inclined with HP. You can see guys, see, when it is resting on one point and when the axis of the cone is inclined to HP, the front view appears as a triangle, the same triangle with some inclination. That's it. Here this is the triangle, it just inclined at an angle. Okay, so now there is no change. So that's why what I am going to do is that instead of drawing it again, so just copying this one, yes, okay, I copied the front view, Control C, Control V, just I am pasting it here. Okay, if you observe, this is the axis of the cone, the angle is 90 degrees, but in the question they are asking axis is inclined at 35 degrees to HP. Right now it is 90 degrees, so to get it 35 degrees I need to rotate. Select everything along with the notations, rotate, enter. Right now I need to rotate the axis, because axis is inclined. So that's why I am taking the base point as this one. This is the base point. Okay, you know that this is 90 degrees. Right now I am going to give minus 55, because 90 minus 35 equals to 55. Minus 55, you can see, because why I gave minus symbol means AutoCAD default direction is anti-clockwise, but I give minus because I want to rotate in the clockwise direction. Minus 55, enter. Now you can see DAN, dimension angular. Perfect. See, axis is inclined at 35 degrees to HP. Now just we need to do a small correction, because they says that it is resting on one of point of its base. Right now it is in the space, so that's why I am taking the move command and I am taking this one and just keeping it on the reference line. It indicates that now this cone is resting on a point E. Here you can see that this cone is resting on point B, because I gave the notations AB, this one here, whereas here this is the notations diametrical point AE. Now this is resting on corner one point E. Okay, so front view also we finished perfectly. What about the top view? When you see this inclined cone, when you see from the top, you can see guys, this half of the base is clearly visible. Is half of the base is clearly visible, means G to A to D, half of the base, the top one. Here you can see that above the axis GC, means this is the half of the base, AHBGC. So this is very clearly visible. So to draw that one, first I am going to draw the vertical projectors. To mark the points, I am going to draw these vertical projectors. And I am drawing the vertical projector from the apex point also. Okay, now let me draw the horizontal projectors from the first point, sorry, first part, not point. Yes, now I'm drawn the projectors. It's time to mark these points. To do this one, I'm going to do mtext, enter, create a small box, B, okay, A1. Let me go for the suffix. Okay, right now I marked as A1, copy, enter, base point, switch off the ortho. Okay, now this is the point, one point. I will let you know what and all the points are those. Okay, one more point is missing. I'll do it later. Okay, perfect. Now you see guys, this is the vertical projectors of A, HP, GC, everything, and this is the horizontal projectors. See, this projector belongs to the C, and here this projector belongs to the G comma C. The common point is C, so that's why I'm named it as C1. Now this one belongs to the HB, and this one belongs to the BD. The common is B, so that's why B. So likewise you can give ABC, D1, E1, F1, G1, H1. Yes. Now I marked all the points. As I said, when you see from the top, this above the axis, this half of the part is visible. A, H, P, G, C. You can see C, B, A, H, G. This half is visible and the bottom half is invisible. Above the axis is visible, below the axis is invisible. So to do that one, I am taking the spline command, SPL, enter, connect, connect, connect. Okay, so this is the half of the base, and now again half of the base I am drawing it here. That's it. Take the okay. So we know that this half of the base is invisible because below the axis is GC, FDE, CD, EFG. You can see it starts from GC, so that's why this is invisible. So to mark this one, I need a load the line type, which is of dashed one, other load. I am taking dashed 2 line for the hidden lines, dashed 2. Okay, for the axis I am taking the center 2. Okay, okay. So this is the invisible line. Now select this one and then give the dashed 2 line. See, it forms dashed line. Very good. So successfully we completed the base, and now we need to draw the apex point. So connect from G2O, D2O, which is the diametrical points. Here in the AutoCAD you can see you need to connect from here, C2O. Okay, so this point is O dash and this is the new point, right? So this one is the O1. Perfect. When you see from the top, this one is also clearly visible. This triangular portion is clearly visible. So that's why let us give a color and some line weightage to this one. So with this we successfully completed the projections of a cone when it is inclined at 35 degrees to HP. Now you can give the dimensions for this one also. The axis, see, 90. Yes, the unwanted portion we can trim it off. Okay, so we completed the projections of a cone when it is inclined to one plane. So just simply I'm going to do I'm copying all these things, copy, just to show a small difference. In the previous case I took this point as a resting corner, so that's why I inclined the cone in this axis. Now what I'm going to do is that instead of this corner E, if you take A, so what will happen? Yes, Control C, Control V. Yeah, okay, I forget to take the base. I forget to take the apex point also. Okay, instead of drawing it again, just I copy it. Okay, Control C, Control V. Okay, I pasted it here. Now instead of taking E as a point, resting point, now this time I'll take this one. Now I'm going to take the resting corner A. So to do that one, rotate, specify base point, this one. Instead of minus 55, now I am going to give 55. You can see. Move. Sorry. Move. This is the base point. Okay. You can check now. Yes, see, axis is inclined at 35 degrees to HP. So now we'll draw the top view. Same like the previous one, draw the okay. So instead of copying and drawing the note, marking the points, just I'm copying this one, copy base point, perfectly. See the same points. Now there is a little variation between this one and this one. If you observe this, in this case when the E is resting, above the axis is AHBGE, so this will be the visible one, whereas in this case now GCFDE is invisible. Now this side will become visible, and this side which is below the axis, when you see from the top, this is invisible. So again, instead of drawing the command, I am just copying this one, just pasting it here. Now you can see this becomes visible, whereas this becomes invisible. So that's the difference. Depends on the resting point. Yeah. Okay. Copy base point. This is the apex point. Perfect. Now let us remove the unwanted portion. Trim. So this is how the difference between these two. So either you can draw the axis is inclined in this case, either in this case, not necessary of two. Either you can approach this method or either you can approach this method. So this is all about the when the projection of a cone, its axis is inclined at 35 degrees to HP. That's it.